Hey folks, this is a video where I'm going to go through the practice exam for test number 3, also known as your final exam for CSE 1322. In this video, I'm going to cover the exam that was hopefully posted into your D2L section in the announcements area. So this is a similar test to what you're going to take on your final exam. To be clear, what I mean by that is the questions that are on here are obviously not going to be the same question that's on your exam, but they're going to be representative of the question that is on the exam. The layout of the exam is identical. There are 8 questions in the practice exam. There are 8 questions in the final exam. They cover the same modules. So if question 1 in the practice exam is over module 1, then you can be assured that question 1 in the final exam is also over module 1. The final exam is cumulative. We are asking you questions across all 9 modules that we have taught you. Having said that, I will go ahead and tell you that there are no questions on module number 4, which was the graphics and GUI module. So in the final exam, you will not be asked to write any code about graphics or GUIs, nor are there any multiple choice or true-false questions or anything like that about graphics and GUIs. So you can safely not study that one if you really don't want to. Having said that, all of the rest of the modules are fair game. So there are 2 documents that are useful, and I'm going to flip back and forth between them. You should have seen this document, which is the final exam study guide. This has been posted in D2L for a couple of weeks now. And what it lists is all of the different modules that we covered and what material was in those modules. So for example, module 1 was the review module. That's where we talked about CSE 1321. Module 2, we did pass by value and pass by reference. We did method overloading, array lists. Module 3 was the object-oriented, where we did inheritance, overriding, super, base, this, public, private, protected, polymorphism, abstract classes, interfaces, casting. There was a lot in that one. Module 4, as I just said, that was the graphics and GUI. There's nothing from that. Module 5, recursion, definitely going to need to know how to write or trace recursion. Module 6 was exception handling. Module 7 was file I/O. Module 8 was threads multiprocessing. And Module 9 was the linked list, stacks, queues, and just a little bit about the binary search trees. So basically, this document explains what topics you need to study. The test is just an example so that you can do a practice and start to feel good or bad about the exam. You will have 150 minutes when you take the exam. So that is 2.5 hours. That should be more than sufficient time in order to get through 8 questions, but you are going to have to write code on a fair number of those questions, so there is that. If you have a SDS accommodation, then you will have potentially additional time depending on what your accommodation is, and that should automatically be added to your test before you start. So you don't have to email me and ask me about that. It is already taken care of if it's appropriate. All right, so this will be taken in D2L like they always are. You're going to open D2L. It's going to drop you into the lockdown browser. You're going to have to do the webcam startup where you show your ID and you go through all of the startup stuff like showing the environment and then getting ready for the test. Once you start the test, you cannot leave the test and come back to it. You have to do it in one shot, so make sure that you are available for the 2.5 hours to take the test and that you are not going to be interrupted. Make sure you have no one else around. It is a quiet space. You cannot have headphones on. You cannot have earbuds in. You cannot use your phone. You cannot talk to anybody. It is you and the test and nothing else. No other laptops, phones, or anything else. You will get a 0. If you get a 0 on the final exam, you cannot pass the class with a B. So I really strongly, I know some people try to go out and do things secretly on the side with their phone or whatever else. You'd be surprised how often they get caught and they end up failing the class. So if you're thinking of risking it, best of luck to you. I don't think you'll probably succeed, but I would strongly recommend you just sit down and take the test and not try to cheat through it. All right, so that's where we are with this. I'm going to go through the questions and I'm going to talk through how to do it. What I would really recommend is that you pause this video as we go and that you actually try to write it before I do. That way you can know whether you got it right before you see me doing it. Because when I do it, it's going to make a lot of sense because, well, I know what I'm doing. What matters is that you know how to do it because this is a similar question to what's going to be on the test. So again, I would highly recommend hitting that pause button down there a whole lot throughout this video and just pulling up another window on the side and attempting to write this. When you're taking the final exam, you will not have access to an IDE. You will be doing it all purely into a text box. So make sure that you remember the syntax while we give you a leeway with the syntax, we still have to be able to understand it. So if you have no clue what you're talking about, it's very hard for us to give you partial credit. As long as it's just a silly typo, like you spell class, C-A-L-S-S, yeah, okay, that's fine. We're not going to take off points for that. But if you don't have the word class there at all, and you're trying to define the class, then yeah, we're going to take off points for that. So just make sure that you remember all of the usual syntax from your language. When you're writing the answers, you can write in either C# or Java. You can alternate in the questions. If for whatever reason you know C# better for one thing and Java better for another, that's fine, we don't care, but each individual question must be in one language and one language only. You cannot use pseudocode at all anywhere in there. If you give us a print statement, it has to be a system.out.println or a console.writeline. You cannot say print. So do not use pseudocode anywhere in the test at all, or that will be marked wrong. All right, so without further ado, I'm going to go ahead and get started and talk through these questions. So question number 1 covers module number 1. And so if we go back up here, you'll remember that module number 1 was basically a review of CSE1321. So in that class, you covered things like variables, the difference between a primitive and a complex data type, reading and writing from the console, conditionals, if then, else, case statements, logical operators, less than, greater than, equal, not, all those, arithmetic operators, plus, equals, minus equals, slash equals, plus, minus, the difference between x++ and plus x, methods, loops, operator precedence, arrays, 2D arrays, classes for defining a class, and the dot operator for accessing a method or an attribute in a class. So that's the fair game. The type of question that we're going to ask you is going to be a problem question. So it's going to be like a math question of some kind. We're going to ask you to do some calculation that's going to utilize maybe if statements, loops, those kinds of things. So here's an example. Using your choice of language, C# or Java, write a method which returns a double, takes two parameters, original cost and years held, they're both ints. The method will take the original cost and will increase its value by 3% every year for the number of years held. For example, you purchase a house for $200,000, that's the original cost, and you're going to hold it for 25 years before you sell it. The method would use a loop or some form of iteration, it could be recursion or a loop, for 25 years to calculate the answer. And the way that would work is in year 1, it's worth $200,000 because that's what you paid for it. In year 2, it's going to be worth $200,000 plus some amount of interest effectively, which is that 3% value increase. The way that you calculate a percentage is that you would multiply the number by 0.03 because that's 3%. To be clear, 0.3 would be 30%, so 0.03 is 3%. So 200,000 times 0.03 turns out to be $6,000. So when you add that together, you get $206,000, and that's the end of year number 2. And that's where we are there. In year number 3, what we're going to have is the number from year 2, which was 206,000, 206,000, that's right. And you're going to multiply it by 0.03, and that's going to give you some number, and add that into the original value of 206,000, and that brings you to 212. And so your loop is going to go 25 times through to do that. So you're not being asked to give a number here. To be clear, you're being asked to write the code that would calculate the number. So I know you're not going to have access to an IDE, and you might say, well, it's a bit unfair for me to use an IDE when you don't get to do it, but I am going to use an IDE just because it's easier for me to type in an IDE and for you to see the syntax. So I'm going to do that. So if you want to do this question, go ahead and hit pause. I'm now going to show you how I would write this. So over to an IDE, I'm going to need some kind of a method that's going to allow me to calculate this number. So public static, it's supposed to return a double, and I'm going to call it calc, and it's supposed to take in 2 items. So when you're writing it, I need you to go back and look at this and make sure that you remember the things that are important in here. So it specifically tells you that it's taking in 2 parameters, this one and this one. They're both ints. It's very clearly listed right there and right there. So make sure you remember that. So original cost and years held are the 2 that I'm trying to do. Okay. All right, so int original cost and int years held are my 2 variables. So that's my method header. All right, even if you don't know how to answer this question, you're going to get some points for just putting in the header. So Make sure you give us the header and the parameters and the return type. Honestly, that's probably worth, I don't know because I don't have the rubric, so I'm not going to make up a number, but it's certainly worth something. So make sure you get that in even if you're completely lost. All right, so how are we going to do this? Well, in the end, I'm going to have to return a double. So I'm going to need some kind of a variable to keep track of how much money the current answer is, because at the very, very end, I'm going to return that. So I'm going to start off and I'm going to say double, and I'm going to begin with, let's say well, I'll call it final answer. And I'll set that equal to 0 for now. And at the end of my method, I'm going to have to return final answer. Okay. Always remember to put in the return statement, especially when you have a method that is a method like this one where you have a return type. Make sure you put in that return statement. Otherwise, you're going to lose a couple of points for not returning what you said you were going to return. All right, so how do we do this? Well, we're going to need some kind of a loop. You could do this with a loop. You could do it with recursion. Might be good practice to do it both ways if you wanted to do that, but I'm going to use a loop because that's the easier of the two answers here. So I'm going to need a loop, and it's going to need to go about however many years they tell me that they held it, which is a variable that I got in up here called years held. So I'm going to use a for loop. So I'm going to say for int I equals 0, I less than years or year held, I plus plus. All right, so I'm going to think about that for just a moment here. So the first year through is going to be year 0. The second year through is going to be year 1, and then 2, and then 3. If they held it for 25 years, this is going to end when I is equal to 25. So it'll work for 24, but it won't work for 25. But I wanted to do 25 years. The first year will have been year 0, and the last year will have been year 24. So that looks like that's going to work. It's going to go through 25 times, 0 to 24. That seems like that. Again, even if you don't know how to solve this problem, make sure you put the for loop in there because it's, again, worth some of the points. You're getting points for each bit that you write, so just make sure you put all the bits in there, as even if you don't know how to use them, right? You'll get points for them from there. Okay, so the next thing I need to do is I need to calculate that. How much did it grow by this year? So I'm going to call this a double. Because again, if I'm multiplying by 0.03, it's possible I get a number that's a fraction of $1. So I'm going to make it a double here. And so what I'm going to do is I'm going to put in, I'll call this new extra value. I don't know, call it whatever you want. And how I'm going to calculate that is I'm going to take the current value of the house, whatever it is, so that's final answer, and I'm going to multiply it by 0.03. Okay? Now, I now need to add that on to my final answer. So final answer plus equals extra value. And I misspelled that. Okay, so this seems like that's approximately right, but there's a couple of things we need to think through here. So will this work on the first year? So the first year through, final answer is 0. When it calculates the extra value, it'll be 0 times 0.03, which is still 0, because anything times 0. And so in the first year, the final answer will be 0 plus 0, which is 0. That doesn't seem right. So then the second year through, well, my final answer is still 0. 0 times, okay, so this is not going to work. I didn't initialize the final answer to the right thing. So what I'm going to instead do is set the final answer equal to 200,000. And then as we come through here, we're going to calculate the extra numbers. Now the problem that we have is, I think this is going to be off by 1, because let's think about this for a minute. The first year, it was supposed to be worth 200,000, but in the second year, it was supposed to be worth 200,000 plus the 3%. In this case, in the math, I'm going to immediately add on some amount in the first year. So I think I'm actually off by 1. I'm going to do 1 too many years. So I think I want years held minus 1 in order to just stop 1 year earlier. Okay, so I know you can't test this because you would not normally have an IDE, but just to prove a point, I'm going to go ahead and test it in case there's a syntax error so that you can see it here, because it is easy to typo a syntax error. So I'm going to call calc, and I'm going to pass it 200,000, which is what was in the example. And I will do 2 years, and we'll see what we get out of that. That's returning back to me a double, and so I'm just going to print it out. And that will give me some kind of an answer. Turn off this hello world that we always get, and we'll let that run in the background here. There really would be no difference if I was writing this in C#. Doubles, ints, the for loop syntax is all the same. So actually, I think I could literally copy and paste that into C# and that would work exactly the same. so I'm not going to bother rewriting it in C# and taking up the time. So hopefully what we should get when that completes is we should get a number that's similar to what was on the test, which is 206,000 with any bit of luck. And Replit will get there eventually. Okie dokie, I'm just going to pause and wait for it to finish. Okay, I feel like it's a baking show, and here's one I made earlier. All right, 206,000 is indeed what came back. I did not change any of the code on the screen. I'm just going to rerun it again for 3, and you can see that in year 2 it was supposed to be 206, in year 3 it's supposed to be 212,180, and I believe that's going to come back correctly. So the important part of this question is not the details of this particular question, because of course it would change. The question you're going to get on the final will not be exactly this, but it'll be something sort of similar where you're going to have to do some kind of a math equation using some form of a loop and or if statements and or that kinds of thing. So make sure that you're familiar with all of that and you're pretty comfortable with the material from this. This should be the easiest question because this is mostly a 1321 question. So hopefully this one made sense. All right, so with that, we're going to move on to the second question in here. The second question is going to cover module number 2. So I'm just going to run back through what was in module number 2. So module 2 was array lists and lists. If you're in Java, it's array lists. If you're in C#, it's probably lists. You definitely need to know how to use array lists. So you should be familiar with using the .add, which is how you put something in there. If you're in Java, .get is how you take something back out. If you're in C#, it's just accessing it with the square brackets to pull out something. Getting the size of it, which is .length or whichever one you're in, and iterating through it is going to be a for each loop. Generally, you're going to use a for each loop anytime you want to go through an array or an array list. So refamiliarize yourself with that if you have forgotten how to do a for each loop. All right, the other things in here are passing by value versus passing by reference. Okay, so the most important thing to remember there is when you make a call to a method, if you are passing a primitive type, which is int, double, float, bool, character, strings even, a copy of what you are passing is what's sent to the method. So if you have a method A and it has a parameter where it takes in an int x, and when you call that with the formal parameters, you say, A open parentheses P or whatever variable you're passing in there, the value of P is copied into the value of A in the method. And what that means is anything that the method does to A is irrelevant to P. P has its own copy, A has its own copy. All right, so anytime you're passing a primitive type, all of the base primitive types, then you are getting a copy of the value. That is passing by value. When you pass an object into a method, so the type in the method, you might have something like public void, do stuff, and then the method name might be enda as the type A. Well, enda is a class, that's an object, so I'm passing an object in here now. If I then say a.x equals 7, I'm changing a variable in A, but it's changing it also in the main method. That object can be altered in the methods above if you pass in an object. So it's a very distinct difference. If you're passing in a primitive type, nothing can change what's happening down below. You get a return back and maybe you assign that to something, but that's the only way you can make changes from the method appear in the calling method, which is usually main. And you're passing an object, on the other hand, the method has the ability to change attributes inside the object. So be very careful that you trace it appropriately, all right? And that is actually what this question is going to be about here in a moment. All right, returning values from a method. If you declare that a method is a void method, you can say return in there, but you cannot say return 7 because you declared it was a void and therefore you cannot return a 7. If you say it's going to return an integer, you can certainly say return 7. You can't just say return because that's not allowed. So if you declare that a method is going to return something, you must do that. You must do it in every path of code. So if you have an if statement in there that says, if x equals this, then do this, return blah, else do this, there must also be a return statement in that else. Every way that it could execute must have a valid return statement. So usually the return statement is going to be down at the bottom of the method because that's where you're going to return. So you're going to accumulate an answer, and then at the very end, you're going to return it. Garbage is anytime that you overwrite a variable, effectively the old version of the variable is just going to be hanging around there. If you make an object, dog, my dog gets new dog. And then on the very next line, dog, my dog gets new dog. The first dog is gone. It's still there, it just can't be accessed. So you have overwritten it, you have made a new dog, which is now taking up that chunk of memory. And so if at the moment you do that, the previous dog is now garbage, and so the garbage collector is going to eventually come along and clean up that dog. That got weird. All right. Last comment on here is method overloading. You can have inside of an object the same method multiple times. Public void do stuff, parentheses, int x. Public void do stuff, same name, parentheses, character y. What that means is that there are two different versions of the method, and depending on which one you call it with, an integer or a character, it will execute one or the other. So that brings us to our question. Okay, so let's take a look at question number 2. And again, question number 2 on your final exam is going to be somewhat similar to this, but obviously not the exact same question. So in here, the code is written in both C# and Java. I'm going to go through the Java side of the code, but it works either way, obviously. So we're going to start off over here on the C# or on the Java side. And the first thing that you can see here is that we have a class called holder, which is going to have a variable in it. All right, this is a public variable inside of holder, which means that anybody who instantiates holder would be able to access that variable directly because it's a public variable. All right, then we have next underneath that, we have a class question2, which is this. And so it has a couple of methods in it. Very specifically, it has a constructor, that's this one. And then it has two methods which appear to be overloaded. And the reason that they're overloaded is because you can see that the definition for both of them is the same. They are both called test. They just take in two different sets of parameters. So this is an overloaded method. All right, so question number 2 is a class. It has an attribute called A, which is public. It has a constructor called question2, because that's what you have to call the constructor, that sets A equal to 17. So the moment that one of these objects is created, we're going to have a variable or an attribute called A, which is initialized to 17. And then we have two methods that allow us to call this particular there's two methods that are overloaded that take in different parameters called test. So then down at the bottom of the screen here, we have the actual main method, and I'm just going to bring this up full screen so that hopefully we can see all of that at once. There we go. All right, and so the question here is, what is the output of this code? So you can quickly see down at the bottom that there is a print statement in both code, and that's down here, that's this print statement. So ultimately, the output is going to be y is something, z is something, and w is something, right? So that's what we're eventually going to write out. So now we have to trace through this code. I know you don't have paper when you're tracing through it, but you can use the text box that is the answer box to trace things and take little notes as you're going. And then at the end, just make sure you erase all of your notes out of there. All right, so we're going to start off here, and we begin with a equals 10. So that is a equals 10 over here, and that's down in our main class. All right, and then we make a new instance of holder, which is this class up here, and we're calling that h. So we now have an h, which points to this class, and that class happens to have an x in it, and x is equal to 4 in that class, right? That's what was up there. And then we make a question2, which I called my q2, and that has an object in it as well, which has an a. And as soon as I call that line, the constructor is going to fire, because you can see I'm calling the blank constructor. So a is immediately initialized to 17, because that's what happens in that constructor right up in here. All right, so now we're on to the next line. So this is the meat of the question, right? We're going to call in my q2, which is this object, the class question2, I mean this object here, we are going to call test, and we're going to pass it h. Okay, now what is h? Well, this h down here we know is of type holder, because that's what we declared it to be. So what we're looking for is a method called test that takes in a holder, which is what we have right here. So even though there are two different methods that have the same name, The one that's getting called is the one that matches the parameter type. I'm passing a holder, therefore it's going to call the one that takes in a holder. Okay, so what happens here is this method gets called and it says a, which right now is 17, minus x.x. Okay, well that's really confusing. So first off, we called the holder x. Down here in main, it was called h, right? But when it came into this method, we called it x. So this parameter x is of type holder. The parameter of type holder has a variable in it called x. So therefore, to access that variable, which is a public variable, we would say x.x. I know that's terribly confusing, and honestly, this is terrible code. No one should ever write this. I made this intentionally confusing just to make sure that you guys understand the distinction on the practice test. In the final, it's not going to be quite this confusing because that would be unfair, but I do need you to understand what's going on here. The first x in that refers to the parameter name. The second x in there, which is after the dot, refers to the x inside of that object. So the x.x here is equal to 4 at the moment, and so 17 minus 4 is of course 13. And we can see in that original line, the value that is being returned by that call is being assigned to the double y. So y is 13 is the answer up there. All right, we're going to move on to the next line. The next line makes a call to test, which is again the same method name, but this time we're passing it in an a. What is an a? Well, it was defined right up here as being an int. So now it's going to look for a method called test that takes in an int, which it has there. So the value of a is going to be copied because it's a primitive type, it's an integer. That was not the case with the previous one. But the value a is going to be copied up here, and x up here is going to now be equal to 10. All right, and then we're going to add to that a. Well, what does the a refer to? Well, the a refers to this a up here that is inside of our class, which was initialized to 17 at the time that we started. So it's 10 plus 17 is 27. And so the output here is 27. All right, and then the last line is w is equal to y plus z, which is going to be 40. Looks like 13 plus 27 is 40. All right, so that's how you would get the output here. There are a couple of important things that I'm just going to go back and repoint out here and mention. So the first thing to mention is that this method, which takes in an object, was called here in the original main method. All right. At the moment that this was called, this h is of type holder. We know that because of there. That was brought up here and is now known as x. If inside of this method I had said something like x.x plus plus, then that would have taken the value that was in the holder and it would have added 1 to it. But since this was an object that was passed up, the value would not only be changed for the x, it would also be changed down here when it was known as h. Because the object is passed, you have the ability to change stuff that's going on inside the object. In this particular case, nothing changed. We were just reading and accessing a variable, but it's entirely possible that you could be asked to change the value inside of this method, in which case you need to understand that not only is it changed in here, it's also changed down here in the original h. So the way to think about this is that when this h was declared down here, I drew it as if it pointed to some kind of an object like this, and I said x equals 4 in there. That's effectively what happened when that line was executed. When this line was executed, and we pass that up to this method here, and we take it in as holder, really what happens is, in the scope of this method, there's a variable called x, which effectively, just like in linked lists, points to the same object. And that's why if I make a change in here, I'm changing it for both x and h. And that's what you need to remember, is that when it is a object that's being passed, think of it like it's a link in a linked list to the original object. But when it is a primitive type being passed, like what happens here, you had an a down here, which was equal to 10, and in the scope of this method here, you have an x, which is just given a new value at the time that it's created, which would be 10, But anything you do to x in here, like x++, has no effect on a because they're not the same thing. So primitive types, totally separate, but objects, you can make changes in both cases. So in this one example, or in this one question, we covered overloaded methods, which is what's happening here. This is an overloaded method. The same name is there. They have two different sets of parameters. So either the type of parameter, which is what's happening here, are different, or the number of parameters. I could have an int x, comma, int y, and that would be yet another overloaded method if it was called test. For the record, the return type is irrelevant. You can actually have different return types, and it's still considered the same method. All right, that's not relevant here. But the number and types of parameters can be different. That means you have an overloaded method. That is the definition of overloaded. Totally different than overridden. That's what we're going to talk about in the next section. All right, so hopefully that makes sense. Passing in values, getting answers back with return statements, assigning them to variables, doing basic math on stuff. That's the kind of stuff that you're going to be asked to do. It's important to understand the difference between passing a primitive type versus passing an object and how they vary from each other. It's important to understand how you would access individual parts of a method. So like accessing, it's important that you understand how to access a variable or an attribute inside of an object. It's also important that you know how to access a method inside of an object. So I think that pretty much covers most of what's going on here in Module 2. All right, so we're going to move on to Module number 3. So Module 3 was where we dealt with object-oriented, where we dealt with the static keyword, interfaces, abstract classes, casting, polymorphism, public, private, protected, super, base. All these things were things that we talked about. So let's take a couple of these together and let's just do a quick review. So the first thing to talk about here is if you have a class A and then it has some stuff in it, and then you have a class B which extends, or if you are a C# kind of person, colon A, then bear in mind that any methods that existed in class A are immediately available in class B. And what I mean by that is if I had in class A, let's say a method that returns an int, do stuff, and let's just say it takes in no parameters like that. So I have a method and then I extended that class. If I then make an object, oops, sorry, put my hand over the camera. If I then make an object of class B, so I say something like B, my B equals new B, parentheses. Yikes, ran out of room, but you know that that's a parenthesis right there. At this point, I can say my B dot do stuff. Even though there is no do stuff inside of class B, that is not in here, it's only in class A. And that's because of inheritance. Anything that is in class A, most things that are in class A, I will have the access to in class B. Now, is that always true? No, it depends on the declaration. Assuming that I had said public on here, then yes, it's absolutely true. Class B can directly call do stuff, life is good. If I had instead changed that such that that said private, then I would no longer be able to access do stuff up here. All right, so that is something to be aware of. That's what the difference is. IVATE. So if it said private int do stuff, class B can no longer do this. I can no longer call do stuff. I didn't inherit it because it was private. If it's protected, then as a child, I am able to access it. So in summary, a child is able to see all attributes and methods of its parent as long as they are public or protected. If they are private, they are not accessible in the child. That means once you create objects of the child, you're able to directly call methods from the parent as long as they were public or protected out in the real world. All right, so hopefully that makes sense. That is the definitions of public, private, and protected, and that is also the idea of inheritance at a high level. We dealt with abstract classes. The rules of abstract classes were a bit goofy. So in order for a class to be declared abstract, you're going to say abstract class Bob. That's a parenthesis, and then you're going to have your curly braces as normal. The kicker is that for an abstract class, which this is now declared as abstract, there can be both concrete methods and abstract methods. An abstract method would be something like abstract int do stuff int x semicolon. Okay, so I am not providing a body here. Very specifically, the thing that I'm about to do in purple is not here, which is what's normally there inside of a method. So I'm not putting in any body, I'm just declaring an abstract method. But in an abstract class, I can still have concrete methods as well. I can say int do other stuff, and then it has its parentheses, and then it has its curly brace, and it can have whatever lines of code it might need to have. So that's the weirdness of an abstract class. There can be concrete methods, and there can be abstract methods mixed in any combination. As a matter of fact, at the very extreme, an abstract class could have all concrete methods, which is a weird thing to do, but you could technically do it. There is no rule that says they all have to be abstract or they all have to be concrete. There can be any mix of abstract and concrete classes in an abstract class. The only rule you have to be aware of is the moment you say class Fred abstract method int do stuff, the moment I cannot draw on the camera. Let me move the camera over there. The moment that you do that, this will no longer compile. You cannot put an abstract class, you cannot put an abstract method into a concrete class. This is declared as a concrete class because I did not specify abstract. And then in my methods, I did declare abstract. That is not allowed. This is wrong, bad. You sit in the corner, think about what you did. But this is perfectly valid up on top, where I have an abstract class and I may or may not have abstract methods in there. Okay, so that's the weird distinction. Everybody wants to say that in a different way, and it's just wrong. Don't do it. The rule is that an abstract class can have abstract and concrete in any number methods. A concrete class can only have concrete methods. The moment you say the word abstract, it will not compile in a concrete class. But in an abstract class, you can have any number, which could be 0, abstract methods. So hopefully that makes good sense, and that clears up some of the confusion on that. So that's an abstract class. Interfaces are simply declared by us specifying the word interface. Interface, Barney, parentheses, and then it has some number of methods. By default, all methods are considered abstract, so you actually don't have to write the word abstract in here. So you just declare methods. It'll be int do stuff, and it takes parentheses, and again, absolutely, you cannot have that inside of a method. These be curly braces. They cannot exist inside of an interface because all methods in an interface are abstract. All right, and then finally, at some point, you're going to have a concrete class real, and then it may extend one class, and it may implement an unlimited number of classes. There could be A, B, C, D, E, F, G, whatever. And if you are in the C# world, there's no difference between those. It'll be the one that you're extending, comma, the ones that you are implementing. They're all just listed. So it might be like A, comma, B, comma, C. If you have an interface A and an abstract class B and another interface C, you can just list them out in comma separated lists like that. The rule is you can extend one, you can implement an unlimited number of interfaces. All right, so those are the basic rules up there. There's also casting, which we're going to see in this example. So let's jump into an actual question here of what you might see. So let me clear that screen, and let me jump back, and let me scroll down. All right, so question number 3 is definitely going to be about interfaces, class definitions, and that type of stuff. So in this example, what's happening is we have a bunch of declarations up at the top. So we have an interface A and an interface B, and you note that neither of those have bodies, like you would expect that they would not. So it has a method A that's declared in interface A and a method B that's declared in interface B. Then we have an abstract class C, which is going to have what looks to be a concrete method and then an abstract method. So it has one of each. And then finally, we have a concrete. This one is abstract, and these guys are interfaces. So finally, we have a concrete class, which is called D, and you can see here it extends C, which is the one above it, and also implements A and B. And you can see the equivalent here in C#. They're just listed out A, B, C. All right? It doesn't matter the order. You can put them in any order you want. So we now have a concrete class, D. It has a method A and also has a method B. And then it also, if I can scroll, has a... that's weird that does that. Okay, it also has an override for method D. So let me clear all this off, and let's talk about what's going on with that. So, clear screen. Okay, so we have interface B and interface A up at the top here had each one method that has to be implemented. So because I have declared that D is going to implement A and B, that is declared right here, and it's declared right there, that means that D must have a method A and it must have a method B. All right? So based on that, I have to have this and this down here in my method D. Otherwise, it will not compile. The moment that I say I'm going to implement something, I have to actually implement it. Beyond that, I'm also extending C. So I inherited method C, from class C, and I also inherited a method D, which was declared abstract, so I better put a method body in for method D. And so you can see down here, I do indeed do that. I have an override for method D. So I can tell that class C has met all of its requirements. It was originally declared as being an extending of C, which was abstract, which means that I had to implement this guy because it was abstract there, and I'm implementing A and B, which each had a method A and a method B that also have to be implemented. I accomplished all of that. I implemented A, I implemented B, and I overrode D like I was supposed to, and therefore I have a valid concrete class, D. All right, so now based on all of that, what the heck is the question asking me to do? Well, based on that definition, continued on the next page here, and in D2L it obviously wouldn't be on a separate page, you're being asked, which of the following statements are actually valid? Okay, so we're going to take these one at a time and we're going to talk about why they are or are not valid. So let's look at line 1, which is this guy. So what's happening here is we're saying A, my C1 gets new A. So I'm trying to create an object that is of type A, that's the type over there, and I'm trying to instantiate a new A on top of it. All right? Well, let's see if that's possible. So let's look back up at A. A is an interface. So the question is it possible to instantiate an interface? And the answer is no. It is not allowed to instantiate an interface. You can never, ever, ever do that. So if you see the word interface, you know that you can never see that. If you see that, it's not valid. You can't do it. You can never instantiate an interface. So keep that in mind, a very important detail there. All right, so let's go back and let's take a look at our second statement. So our second statement is, I don't know why you're being like this. There we go. Our second statement is B, my B, is equal to new A. So we know that this one is bad. B gets new B. Well, B was also an interface. If you look back up at the top, you'll see it was an interface. I'm not going to go to all the trouble of scrolling. So I know you can't do that. You cannot instantiate an interface, period. So the fact that it says new B here is the part that you know that means it's not going to be doable. I'm going to pause for a minute and figure out why my pen has become so thick. Okay, I've decided it's always been that thick and I'm just crazy. Good. All right, so You cannot do new A or new B because those are both interfaces. So you can immediately look at all of these statements and see anywhere you have a new A or a new B, not going to work. How about C? Are we allowed to do a new C? Well, the answer there is a little bit more nuanced because C is a class, but it's an abstract class. The rule is you cannot make new abstract classes. You're not allowed to define an object that is an abstract class. So therefore, this one is also bad. So far we know that line 1, line 2, and line 3 are each going to cause compiler error, which is what it's asking you to list out. All right, so let's take a look at the next one. So D, my C4 gets new D. So the question there is, are we allowed to make an instance of D? Well, D was a concrete class, and it did everything it was supposed to do. It implemented the interface for A, it implemented the interface for B, and it overrode method D, which is what it needed to do in order to extend C. So yes, D is a valid class, and you can absolutely instantiate it. So the good news here is that D is valid. I am indeed allowed to do this one. So that one is a yes. All of the other ones were no's. I'm just going to make those into X's. All right, and then I'm going to, right, there we go. So red means no, green means yes. Keep that in mind. All right, so our next statement is A, my C5 gets new D. All right, there's two things you have to check in order to know whether this is going to work. So first off, we're going to look at the second part of it, which is the new D. Is D something you can make a new of? The rule is, if it's an interface or an abstract class, no. If it's a concrete class, yes. So D is a concrete class, therefore I am allowed to do that. The second thing you have to check for is the type of variable that you're trying to put it on. So you're making this new D, what can you put it on? And the answer is you can put it on anything that is a D or parent of D. All right, so in the previous line, in line number 4, you did D gets new D. That's the normal, that's not polymorphism, that's just the normal instantiating an object. But this line 5 is polymorphism. I'm trying to create an object of a new D object, and I'm trying to stick it on an A type. So the thing on the left is a type. And if I had said int x equals 7, you would inherently know that x is an integer, right? That's what this means. The order is you specify the type, and then you specify the variable name. Well, that's exactly what's happening here. I'm saying A, which is a type, my C5, which is a variable name, is getting a new D. So A is the type. So the question is, can a variable of type A hold a new D? And the answer is yes. Why? Because D is a child of A. Very specifically, if we look at the definition of D, which is here, you can see that it implements A. If it inherits from, i.e. extends, or if it implements a class, then it is a child of that class. D is a child of A, B, and C. A parent, D. B parent, D. C parent, D. It is a child of all three of those. Even though A and B are interfaces, you can still use them as a type. You can also use an abstract class as a type. All of that is valid. So, in summary, the question here was, can you say A, my C5 equals new D? And the answer to that question is yes. Line 5 is a perfectly valid line. You can absolutely create an object of type D and set it on top of a type A. So you're making an object D and you're putting it on something that is of type A. Likewise, you can do the same thing for each of these. So type B, because it's a parent, and type C, because it's a parent, can each hold new Ds. So the two rules that you need to look for polymorphism is the thing on the right-hand side where it says new D. Is that instantiable? I cannot say A gets new B. That's not valid because even though B is well, actually, it's not valid for two reasons. A and B are not related to each other. There's nothing that says B is a child of A. So therefore, you can't do that. And the second reason is B is not instantiable because it's an interface. But If I had had C implements A and then D extends C, you still cannot say C gets new A. That's not valid because A is not instantiable. So the thing on the right-hand side where it says new, that must be instantiable. It must be a concrete class. And it must also be a child of the type that's on the left-hand side. A child being it implements it or it extends it, being the Java words in the C# world, it is after a colon, it is a child of the parent. All right. So the answers to these questions specifically are the red and green lines. If there's a red line, it is not valid. If there is a green line, it is valid. All right. So let's go on to line number 8 and let's answer some more questions. So now it says my C4, which is this guy up here, my C4.methodB is what it's trying to call, and it's trying to pass it the number 10. So D gets new D is what's happening. And what we're trying to do is we're trying to call method B and pass it an integer. So is there a definition inside of D for method B? And there is. There it is right there. I just pointed to it. So yes, I can absolutely pass an integer into method B. That is a valid statement. So the object that is of type D, or the new D object, is allowed to call a method called method B because it's right in there. So this line, line number 8, is perfectly valid. I am allowed to do that, no problem whatsoever. All right, let's take a look at the next line. My C4 dot method C. So again, this is D, my C4 gets new D. So it is a D object sitting on a D type, and I'm trying to call method C. Is that allowed? Well, let's go up and take a look at that definition. So the first thing that you notice is that there is no method C listed here inside of this object. So you might immediately say, no, that's not going to work. But remember, D extends C. So if we scroll back up to C, there is a method C up here. There it is right there. And remember the rule that as long as it's public, which it is, and as long as you extend that parent, which you did, then objects of type D have access to that method. So down here, I implicitly have a method C that takes in an int x. That's implicitly here inside this code. You don't have to write it because you inherited it from your parent. So it is perfectly valid for me to call method C on an object that is my C4, which is a D object sitting on a D type. So yes is the answer to that question. That is also valid. All right, let's move on to the last two, because these are a bit more difficult. My C5 is going to be looking at this guy, which is a object D sitting on type A. So the type is A. That's a really important distinction here. The type of this variable, my C5, is of type A. The compiler is going to attempt to type check this for you. So the code that's written says my C5, which is of type A, dot method D. Don't get hung up on the D part of it. What we're going to do is we're going to take a look at what's happening here. So my C5 is the type that is an A, which I just highlighted. So I'm going to scroll up, which is what the compiler will do, and I'm going to look for a method D inside of A. Well, there is no method D inside of interface A. It's just not there. So the compiler is going to compile error at this point. It's going to give you an error message that says there is no method D in type A. Now, the reason that this is confusing and the reason that you may be thinking, but wait, is because what was instantiated on this variable was a new D. And we just said that a new D has a method D. It's right there. As a matter of fact, there's an override for it right there. So in your head, you're probably thinking, but I made a D, and I want to call method D, which is in D. Why is it not letting me do that? And the answer is the compiler type checks based on the type of the variable. And if I said this in this way, if I said int x equals 7, double y equals 3.2, x equals y, you know in your head that the compiler is going to poo on that. Why? Because you can't assign a double to an int. That's not allowed. The compiler type checks it and says, no, this is not valid. You can't do that. There's a type mismatch here is what's happening. This is a type mismatch. And likewise, when I'm over here in my code and I'm attempting to call method D inside of my C5, which is of type A. It is of type A. That's the most important part of that. It is not allowed because there's a type mismatch. Type A does not have a method D. How do you get around that? Well, it's the very next line on the screen. If I had cast my C5 to type C, then all of a sudden it works. Why? Because type C has a definition for method D. Come on now. Type C, I'm just going to clear the screen because this has gotten completely out of hand. Okay, type C has a definition, because type C is this guy, for method D. It's right there. So the compiler is okay with it this time. So when you are looking at a method call, which is what's happening here, you're not looking at instantiating new objects. Each of these are method calls. When you are looking at a method call, what matters is the type of the variable. The type of the variable is the left-hand side, not the right-hand side. Okay, this my C5 is of type A. Once I cast it to C, which is what's happening there with those parentheses C, and it's the same exact syntax over here in C#, now it acts like it is of type C, and the compiler is fine with it. It sees that that's valid. I could have also cast it to type D, and it would have worked fine as well. But as long as it's an A, it doesn't have a method 5 according to the compiler. All right, so that's the important thing there. So hopefully this makes sense. If you're a bit lost on this, remember that the other videos are still on the YouTube channel where you're watching this one from. You can go back and re-watch the lecture about polymorphism, where I went through these examples many, many times in there as well. So that is question number 3. And now we're going to move on to the next module, which is module number 4, which is graphics, which, as I said, there are no questions whatsoever on module number 4. So you can forget about module number 4 and move on with your happy life. All right, that brings us to module number 5, which is where we're going to talk about recursion. So the thing that you need to know about recursion is you're obviously going to need to be able to code recursion. You're also going to need to be able to trace recursion. So let's take a look at the question on this test, on this practice test. So the first thing that we have is question number 4. You are being asked, using your choice of language, C# or Java, write a recursive method which takes in an array of characters and a position as an int and should return a string which is the reverse of the array of characters starting at the position passed in. So for example, if you were passed in an array with A, B, C, D, E, F like that, and you're calling reverse array, which is what we just are writing, you're being passed in the array and you're being passed in 0, it would start at position 0 and it will give you the reverse of everything up to position 0. So that gives you back a string that is FEDCBA. All right. If it was called with new array in position 4, then the Y that is returned would be FE because it's only starting at position 4 and moving up there. All right. So the first thing to think through here is, what's your base condition going to be? So it looks like your base condition is you're going to keep moving until you hit the end of the string or the end of the array. So you're going to need to look at the length of the array for sure. And when you get the passed in position, the thing that you're using as a parameter here, this position, when that reaches the end of the array, then you know you're done. That's going to be your base condition, right? And the reason that I came up with that is because I looked at the 2 examples that were given. And in this case, they started off at position 4. So we know that this is 0, this is 1, that's 2, that's 3, that's 4, and that's 5. So clearly they started here in this second example, and then they moved over that way. And effectively what they returned was the F followed by the E, and then they just stopped. So the base condition is going to be starting at that position when you reach the far end of the array. All right? So again, I'm going to clear the screen, and I'm going to go ahead and start coding this. So I'm just going to take a minute to wipe out the replit and start up. Okay, so just to save a little bit of time, I copied the example that it gave in the question, again, just so that I can test in here. And I'm also making a call, passing it in, I guess, 0 the first time to make sure that it actually works. So this is just calling something called reverse array, which is a method I'm going to have to write, and I'm passing it in the example array and also the 0, which is the position. So again, to be clear, it says write a recursive method which takes in an array of characters. That's the very first thing. So I'm going to have an array of characters and a position as an int. So I'm taking in 2 parameters. The first one's an array of characters. The second one is a position, and it's supposed to return a string, which is the reverse of those characters. All right, so I'm going to do this in Java. I will then translate it into C#, and I will show you how that looks in C#. It is a little different because of string here. All right, so public static. This is going to be a string return type, and I'm supposed to call it reverse array in this case because that's what I called it down here at the bottom. All right, so it's supposed to take in 2 parameters. The first one is a character array, so that's a char array, and I'm going to call it my array. And then the second one is a position, which is an integer, and so that's how that's going to look. So again, even if you do not know how to do this method, make sure you put at least in the header and get that. All right. Anytime that you're going to do a recursion and you're going to be building a string, you're going to need a temporary holder to hold on to that information as you do the recursion. So I'm going to start off a string called return string maybe, which I'm going to call, that's terrifying a little bit that it already knows what return string is. And at the very end of my method, I'm going to return string. All right, so starts off as blank. It's going to end up returning whatever this is in there. All right, so now I need to do my recursion. So I'm going to need 2 things for recursion. The first thing is I'm going to need a base condition, and the second thing is I'm going to need a recursive call. Let's deal with the base condition. So I got in a position which tells me where I am in the array, and I'm supposed to keep going until I get to the very, very end. So the first thing that jumps to my mind is I'm going to need something like if position, this is not exactly right, if position is greater than or equal to maybe myArray.length, then I would need to do something because that's my base condition, else, and again, this is not exactly right, but so there's something in here maybe, and then at the end, I'm going to have my recursive call. Okay, so that's basically where we're headed. I think I'm going to start off with this position. It's going to be 0 the first time that it's called, which means it's going to be at the very far end of the array. And then in each of the recursions, I'm going to keep moving it over and over and over. And the obvious choice is that eventually I'm going to get to the end of the array. All right? So the first thing to think is, how do you come up with these base conditions? It doesn't seem like it's very obvious sometimes. Well, there's only a couple of different possibilities here. With an array, you're either going towards 0 or you're going towards the array.length. That's really all you can do. Unless they're passing you some other parameter that tells you to go from position 2 to position 8, then, okay, you want to go to 8. But normally you're going to go towards 0 or you're going to go towards the end. It would be helpful if I spelled length right. I see that here while I'm talking. So important to know, you're going to have some base condition that goes towards the end. All right, let's come back to the base condition in a moment, and then we'll realize that that's not exactly written correctly. So let's talk about the recursive call here. I'm going to get in this array, A, B, C, D, E, F. And what I want to return is the reverse of it. So it seems like what I want to do is I want to keep recursing until I get to the end, and then I want to start adding each one of those characters onto the string in reverse. So effectively what I just said is, I want to take that return string, which right now is blank, and what I want to do is I want to add to it something that I'm getting from my recursion, which is going to be something, and then I'm going to add on the current letter that I have, which is my array at position. Okay, so I put in square brackets there, not to mean that that's literally what I'm going to put in. That's just a placeholder. So what I'm telling you is that I got in this array that has a whole bunch of stuff in it, right? And I got A, B, C, D, E, F. Okay, that's all I got. And effectively what I'm trying to do is I'm telling you that the return string is going to get something plus whatever the current letter is. Now, how do I know that that's what I want? Well, I'm trying to reverse something here. So if we take a smaller case, and that's how you always think about recursion, don't try to solve it with the big long array. That's really confusing. We're instead just going to talk about a much smaller version of this array. We're going to talk about this. So position is 4, which is this cell, the one with the E in it, and then there's an F after there. So effectively what I want to do, if I was being called with position equals to 4, I want to make one more recursive call, which would be to position 5, and then I want to take the value that's in position 5 and add it to the string. Okay, so that means that I would put in the F as my return from the position 5, and then I want to put in the E when I was back at position 4. So in position 4, this is known as my array at position, because position 4 is that. But I want that to appear after I do whatever other recursion is in there. And that's the beauty of recursion. I don't have to worry about how is it going to get the F and all the other stuff. I just have to care about, I'm going to make the calls to recursion, and I'm going to hope that they give me back an answer. When they're correct, I'm going to append an E to it, because that's what I was supposed to do when I was called. All right, so let's take a look at this now when you're at position equals to 5. So in this case, which is going to be the next call, right? Position 5. So in this call, there is nothing past this. It's going to make a recursive call to 6, which doesn't exist. That one's going to return nothing. So then in recursion 5, it will have added on the F on here, which is why you got an F back in 4. I know that's all a bit confusing, but effectively what's going on here is don't worry about how does it calculate the next thing. Just worry about each individual call. So to be clear, the simplest case is that you are called with position equal, good Lord, eraser, please, there we go. The simplest case is that you're called with the position equals to 5. That's this guy. So what you're going to do is you're going to return string is going to get some recursion from past that point, whatever that ends up being, plus F, because that's the position 5. It turns out when it makes the recursive call, it's going to try and look in position 6, which there is nothing there. So that's going to return nothing. So when that exits and you come back to position 5, what you end up with is return string equals F. All right? So now based on that, let's look at position 4. All right, so in position 4, one of these days I will count that correctly. Position 4 is this guy. What we're getting is return string is going to be plus equaled whatever you get back from 5 plus the E. Well, we just saw what you get back from 5 because we just did that. You got an F. So if we fill that F in, which is how recursion works, you see that we get FE. All right, so the return from position 4 is going to be FE. And now, based on that, if you look at position 3, I think it's fairly obvious what's going to happen. You're going to take the FE from position 4, and you're going to add a D to it. And if you look at the one before that, you're going to add a C to it, and then you're going to add a B to it. So that tells you that you need to put the particular thing that you're looking at right now after your recursive call. It's because you're trying to reverse something. But that's specific to this example, right? If they're telling you to just print out the numbers in the same order, then you don't need to put them in reverse. You only need to do that if you're asking for them to come back in reverse, okay? So hopefully that makes sense. So we're trying to figure out how to get all the letters back in reverse. So back over in my code, I put in a placeholder for this recursive call, but let's actually fill that in now. A recursive call is a call to my own method. My own method is called reverse array, and it takes two parameters. The first one was my array, which is not going to change. The array is going to be the array, and the second one is going to be the position. Now, if I were to just leave it at position, which is wrong, the problem is the recursion would continue happening forever and ever and ever. I would always be calling myself with position 1 or position 0, position 0, position 0, position 0. I'm never getting closer to my end case. So in my end case here, I was looking to get to the length of the array. So I need to keep moving to higher and higher positions, which means in this particular example, I'm going to add 1 to my position. So I'm making a call out there. All right. So this is the correct recursive call that's down here. Now, we still have a problem with the base condition. So let's take a look at the base condition. So let's think through this for a moment. So if I'm called in the worst case scenario, let's think through this. I'm either given a 0, I'm given some number in between, or I'm given the full length of the array. So first off, how big is this array? 2, 4, 6. So if I ask for the length of this array, and I'm just going to write that down up here, it's going to be 6. But that really means that I have cells 0, 1, 2, 3, 4, and 5. Okay? So very important to remember that everything is indexed from 0, so that's always going to be a little weird. So now let's look at our base condition. Would this work? So my length, my array.length, well, that's equal to the number 6. So what I'm saying is if the position is greater than or equal to 6, well, by the time it gets to 6, we have a much bigger problem, because if it ever tries to access position 6, which is going to happen down here, it's going to crash. You can't access position 6 in an array of 0 to 5. So clearly, the greater than or equal to is a problem. So let's get rid of the equal and see if that's correct. So what I'm saying here is, if they give me something that is greater than the array length, then what do I return? Well, if they're asking for the 6th position in an array of 0 to 5, then maybe I give them nothing. It seems like at that point, the return string would simply be blank. Okay, so if they give me a position that is past the end, I'm going to return back a blank. If they give me a position that is lower than that, then I'm going to make this recursive call and keep chugging through until I get to a right answer. Now, you can probably tell that there's an optimization here. I don't have to do this because I've already set it to blank up here. So in reality, I could just collapse this out completely. So if you're already confused, ignore what I'm going to say, but it is also possible for me to just simply say, and this would actually happen before the else, I could comment everything out above this and simply say, if position is less than my array.length. And then all of this can be removed because that's the same code. I don't have to actually set the return string to 0. All right, so if that didn't make sense, don't worry about it. I'm just going to remove this and leave it as is. You will always still have a base condition. The base condition may do nothing, which is kind of what's happening here, but then you're also going to have a recursive call. So if we plug this in and we hit run, assuming that I didn't do something stupid, I should get out FDCBA, and I did do something stupid, and the thing that I did that was stupid was I spelled position, P-O-S-I-T-I-O-N. I spelled it wrong. All right, and so I should get back FDCBA in this case, and I didn't, and that's because I'm going outside of the bounds of the array, and that is because of the way that I wrote this. Okay, so I actually didn't catch the circumstance I was trying to catch. If the position is greater than the array length, return string. But in actuality, if the position is greater than or equal to the array length is when I need to stop, because the array length of 6 is not a valid cell, so I needed to actually stop before that. All right, so we can see that gives me FEDCBA, and if I call it with 4, which is the example that it was supposed to do for the smaller one, I should just get FE, which is the last 2 letters. And if I do call it with 6, I should get a blank string, which is the other thing to check for, because there is no cell 6, so we want to make sure that that just returns back an empty string, which is what it did. All right, so hopefully that makes sense. You are going to have to either write a recursive method or trace a recursive method. There is no doubt. There is a good example on test 2. You can go back and look at that. There are plenty of videos on YouTube from me for recursion where I went through a bunch of examples. If you're still confused, you can go through them. But the important thing to remember is you're trying to figure out what the base condition is, and then you're trying to figure out what the recursive call is. And hopefully the way that I worked my way through that might help you to figure that out. You won't necessarily be dealing with an array of characters in your test. You may be dealing with something else, but the idea is always still the same. All right, so that is question number 4. And so we're going to move on to question number 5. Question number 4 covered module number 5, which was recursion. So the next module we're going to talk about is exception handling. All right, in exception handling, we talked about building custom exceptions. We talked about wrapping things that could fail in a try block and then having catch blocks below it. We talked about throwing exceptions for when we needed it. Before I do this, I'm going to pause and I'm going to put the C# code up from the previous example. Okay, for my C# folks, I almost forgot to show you the code. There's not really a huge amount of difference from that recursion example that we just did a moment ago, but very specifically, I'm just going to quickly highlight the things that were different. Lowercase string, uppercase length, lowercase string, and other than that, I believe I copied and pasted. I don't think anything else changed down at the bottom. Oh yeah, obviously console.writeLine instead of system.out.println. But those are the only changes. So that is the equivalent code here in C# for recursion. All right, sorry about that. So I'm going to pause again, and then we're going to prep and get moved on to exceptions. Okay, so in question 5, you are being asked to take a file, read it in, parse some of the information out of the file, and do some calculations to get to a final answer. So there's really only 2 things that we could really ask you from this module. This is obviously module number 6, which is the file I/O module. Realistically, we could ask you to read information in from a file or write information out to a file. That's really what we would be doing. What I meant to say was, for module number 7, file I/O, we would either be asking you to read or write. This one question is actually going to cover both module 7 and module 6, because module 6 was exception handling, and that's where we were dealing with try and catch blocks. So what we're doing here is we're going to have you read from a file, which is a great example where you have to deal with try catch blocks on this question. So the question specifically on the practice exam is write a method which takes in a file name, which is a string. You should expect the given file to have 2 numbers that are comma separated per line. Read in each line, multiply the 2 numbers on the line, then sum all the lines. Return an integer, which is the sum of the lines. So for example, you're given a 2 and a 5 on the first line, and so that would be 2 times 5, which is obviously equal to 10. The second line will be 3 times 6, which is equal to 18. And the third line would be 4 times 7, which is 28. And then you're supposed to return the sum of those, which is 56 by my count. Okay, and that is what it shows as an example. So that's what you're trying to do. So let's talk through how you're going to do that. Well, you're going to have a file, so therefore you're getting in a file name. You're going to use whichever object is appropriate for your language to open the file, which is probably going to be file as an object in Java, followed by scanner, which is how you would read in text lines, or over in the C# world, you're going to use print reader. And I have stream reader. That's why I looked it up, because I'm like, I know I'm going to butcher that. So I have written the code for both of these, and I'm just going to go through it rather than writing it live, because I realize that takes a lot of time, and I'm trying to keep the length of this video down. But what we're going to do here is, if you are coding along, you should probably pause your video right now, and you should go ahead and attempt to write this. In order to do this, you're going to need to catch all of the exceptions that you might have, which are I/O exceptions effectively. So that's what we're going to do here. I'm going to do this in Java first. I'm going to walk you through the answer, and then I'm going to walk you through the answer in C# because they are slightly different in this case. So again, write a method. It's going to take in a file name. It's ultimately going to return an integer, and we're going to do all this fun stuff of pulling in the lines and splitting them bit by bit. So this is the answer in Java. I have read into Replit. I have added in a file called a.txt, which I have put the example into. And then in the code, I am down in my main method. I am setting up a file name, which is a.txt. That matches the file name that I have here. And then I'm calling a method called SumFile just to allow me to get an answer and then actually print out that answer just to make sure that I can see that it is working correctly. All right, so that's just my minutia of doing that. Let's actually look at the method. So the things to note here are we start off and we are supposed to have a method that eventually returns an integer. It's supposed to take in a file name, which is going to be a string, and then it's going to go through the file and it's going to calculate an answer. So anytime that you're calculating an answer, you're going to need some kind of a variable to hold something. It probably should match the return type, which it does. So I have an int that I'm returning there. And so then we get to the meat of this. So I'm going to have a try-catch block around my code that is doing all of the file I/O. And this is important because anytime you deal with a file, it can absolutely throw an I/O exception. I may also have other exceptions that could come out here, and we're going to look at those as we go along as well. All right, so the code in Java for reading in a file is you're going to create a file object. So my file gets new file, and you're going to pass it in the file name, which matches the file name that you got in as a parameter. And then you're going to use scanner. So scanner, I called it file scan, gets new scanner, and instead of passing system.in, which is what you're normally passing, you're going to use the file that you just created up above it. Once you have an object that is a scanner, and of course, in order for this to work, you do actually have to have scanner, and you're also going to need Java IO star, so you would need to include those in there as well. But once you have those added in, then you're going to start walking your way through the file bit by bit. So everything in this little box that I just drew is the remainder of the work. So what I'm going to do is I'm going to read one line in, which is going to be a string. I'm going to break it up into the two parts based on that comma. I'm going to convert both of those to integers. I'm going to multiply one by the other, and I'm going to add it to my total, which is what's going on up here. So those lines are going to be, I start off and I create a string, which I'm calling line, and I'm going to read that in using next line, which is a method in scanner, and that gives me a string that represents that line. So to be clear, what I'm getting out of that is going to be come on, you can do it. It's going to be an entire line. So the first time through, it's going to be 2, 5. It's going to be that whole line up there. All right, so that's what line is going to be equal to when I have read in one line. All right, so the next thing that I'm going to do here is I'm going to take that and I'm going to break it up into its constituent parts. So I'm going to use the string split method, and I'm telling it I want it to split based on a comma, and that's going to give me an array of strings, which I called bits, because there's the bit over here and the bit over there. All right, so that gives me an array with 2 cells. I then have to convert each of those cells into integers, because right now it's an array of strings, so I have to convert them into integers, and I'm using integer.parseInt on each of those. Then I calculate the product of the two of them, which is simply multiplying the first one by the second one, because that's what it told me to do, and then I add that result to my total. So effectively, as long as everything is going well, what's going to happen here is I'm going to open the file, I'm going to create a scanner object. While I have more lines in the file, I'm going to read in that line, split it, convert them to integers, multiply them, and add them to the total. So as it runs through this over and over and over again, that total is just increasing with its number. So that's the meat of the question. The other thing that might happen here is we might throw an exception. So let's look at the possibilities. So at the time that I create the file, that could be an exception. At the time that I use scanner to try and read from the file, that could cause an exception. So both of those need to be within the try block, which they are. To be fair, there's one other exception that I really should have caught here, which is at the time that I try to convert the string into an integer, it's possible that I get a formatting exception on that one because I could be trying to read in a file that has some other junk in it that is not appropriate. So just to be absolutely sure, there's never any harm in catching exception after you've caught whatever it is that you think you're likely to catch. And I'm just going to put in another print line statement here. And in both of these cases, I am printing out e.getMessage, which is going to give me back the actual text of the message. That's how you pull out the text of the message. And e is simply my variable name that I have there, which is my exception. At the end of that method, I am returning total. So that is the Java version. If I run it, I do get 56, which is what I'm supposed to get. I'm going to flip over to the C# version now, and I'm going to walk my way through that. Substantially, the code is very similar to what I just did in Java, but I'm just going to walk through it because it is slightly different. So again, you were to write a method which returns an integer and it takes in a file name. We are going to use a total variable, which is going to allow me to keep track of everything that I'm doing. And in this case, I'm going to use stream reader, which is going to allow me to read in a file and do stuff with it. In order for this to work, I do need to have system.io included or used. So I have a file scan is what I called my method, file scan is what I called my variable. And so it is effectively the file. The syntax in C# is I'm going to say while not filescan.endofstream, which is going to be true as long as there are more lines for me to read. Then I'm going to do a read line on filescan and assign that to a line variable, which is just a string. And then I'm going to use that split method on line to split based on the comma. And that again gives me an array of strings, which is called bits. And then I convert those into integers. And the syntax there is int32.parse. And I'm passing it bit 0 and storing that in num1, and bit 1 and storing that in num2. And that gives me two numbers that I can now multiply together, and I can add that to my total. So again, it's going to read in the line, and we're going to go through this loop over and over again. As long as there are lines in the file, it will stop when it reaches end of stream, which is the end of the file. And as it's going, it's splitting them and then multiplying them and then adding them to the total. So by the time that I pop out of this loop, that total variable will have more than 0 in it. And so down here, we will eventually return total. So likewise here in C#, I'm going to catch an IO exception in the case that anything in that try block that I have up here fails. And again, the likely scenarios there are it tries to read the file is not readable, it's not accessible, it has a permission denied error. So those are the likely things. And again, at the int32.parse, it is possible that throws an error. So I'm going to add in a bit of code there that says probably could phrase that better, and it's e.message is how you access the message in C#. So the important things to get out of this: you need to know how to open a file for reading, which again is going to either be stream reader, or over in the Java world, it's probably going to be the combination of file and scanner. You need to know how to read a file in, which is going to be next line in Java. It's going to be read line in C#. And you need to understand how to stop when you reach the end of the line, which is going to be has next line, or it's going to be while not end of stream. That is how you're going to read. There are other ways in both languages. Specifically in Java, there's at least 3 or 4 different ways that you can do that with buffer reader and all those fun things. And you're certainly welcome to use those. Print reader is another one. But you just need to know how to do it one way for sure. You need to know how to read in a file and do stuff with the file. You also should understand how to write out a file and do that as well. So make sure you review that in there. As far as exceptions are concerned, you need to understand how to catch an exception, which is what's happening here with these catch blocks. You need to remember that the order in which you do the catches is important. They have to be in hierarchical order in reverse from the most specific to the least specific. The least specific one is going to be exception, and that's true in both Java and in C#. In that case, that's the highest level exception that you can catch, and therefore if you catch it, you catch everything, all of its children, which include I/O, parse errors, index out of bounds errors, and all of those. They're all children of exception. So if you have something more specific, you catch it before you catch exception so that you're able to do different error messages for each of them. All right, so make sure you understand try blocks, make sure you understand catching, make sure that you understand how to throw an exception, which is not something that I'm showing in this example, but you definitely need to know how to do that, and how to write a custom example. There was a good example of that on test number 2. So that pretty much clears up the exception handling and also the file I/O handling question, which was question number 5 on this example. And again, something similar is going to happen on the test. So we're going to move on, and we're now going to talk about question number 6, and that's going to be from module number 8, which is where we talked about threading and parallel processing. So the things that you need to be aware of from threading and parallel processing are you need to understand how to divide work up into threads, you need to understand how to start, how to interact with a thread, how to put a thread to sleep, and you will need to understand how you go about writing a thread. So again, this is going to be different depending on whether you're in Java or in C#. In Java, you're most likely going to implement runnable, which is an interface, and then you can create threads based on that runnable, and you must have a run method, and that run method is going to be the actual worker that does stuff. There's a great example of this in the horse race, in the example or on the video lecture, so if you need to go back, you can certainly take a look at that. In the C# world, you can call the object whatever you want. It doesn't implement an interface, and then you're going to use the thread start and then the thread in order to create it and specify which method you want to run when the thread is started. So let's take a look at the question that we have here. So in this case, it says, write a class called counter, which can be used as a thread. The counter class should count from 5,000 to 0. In your main method, create 3 threads of counter and start them. So again, I'm going to pause, and I'm just going to go ahead and write the code, and then I'm going to unpause when I'm done, just so that you don't have to sit here watching me typing. So again, if you want to pause and do the same thing, do that, and we'll be back in a second. Okay, so for question number 6, we are asked to create a class called counter that can be used as a thread. It should count from 5,000 to 0, so it's going to print out 5,000, 4999, 4998, etc., etc. In your main method, you're going to take 3 threads and start them. So this is definitely syntax that you need to know. The syntax is going to be different between Java and C#, so we're going to start looking at the Java code first. So the first thing that I did here was I created a class counter. And the important things here are, in Java, you're probably going to implement runnable if you're going to do a thread. This is not true in C#, but in Java you want to be class counter implements runnable is what you're going to go for. And then you must, basically what that entails is that you must overwrite public void run. That's pretty much the only requirement of runnable. So once I have a run, I can put whatever code it is that I want to do in there. So this code is incredibly simple. It's just a for loop that counts from 5,000 down to 0. I will say that the first time I wrote it, I put a plus plus there because I'm just so used to doing that, but obviously it is a minus minus if you're looking for 5,000 down to 0. All right, so that's our counter class. I'm going to flip over to C# and I'm just going to show the same class there. So the class is pretty much identical. The only thing that's different is I'm not implementing runnable. But I called my method in here myRun just to prove the point that you can call it whatever you want in C#. You have to call it run in Java. Okay, so there you go. That's your class. And then beyond that, we also have our main method. So in here, we were told to instantiate 3 versions of our class. So the first thing that I had to do was I made 3 versions of the class, i.e. I made 3 objects of the class. I call them C1, C2, and C3. Each of them is a new counter. So I have 3 new objects, C1, C2, and C3, that each have that run method inside of them. I then created a thread for each one of them. And so thread T1 is a new thread, and I'm passing it the object that I instantiated just a moment before that. So I did that for T1, T2, and T3. So that makes 3 threads. So to be clear, I made 3 objects of counters. Now I've made 3 threads, each of them with one of those objects. And then the last thing that I have to do in Java is say start. When I do that, in Java, you're going to see that it's going to compile and it's going to start running. And then the output's going to be a bit weird. You're going to see these 5,000s counting down. But in actuality, if you scroll back up through that window, you'll see that the same number appeared 3 times because there's 3 different objects in there that are printing stuff out. And so, like, for example, if I go up far enough, you'll see that some of those actually did print out. There you go. There's the other one. The order in which those numbers come out, completely random. It's based on the scheduler for the operating system. So you'll notice that like one of them was interrupted. It got all the way to 0, but this one was interrupted and then picked up from 659, which is right in the middle of 5,000. So this was a question on one of the quizzes where we were asking you, what is the output of this code? And the answer is, you don't know. You will get all numbers from 5,000 to 0, but the order in which they come out, completely non-deterministic. It's up to the operating system to decide that. All right, so that's the code you need to remember in C# if you are trying to build threads and have them run. You definitely need to start the threads. That's very important. You need to create threads that are based on objects, and the objects that you're creating them on, you have to have instantiated just beforehand. So make sure that each of those threads is instantiating one of those objects. All right, so that's the Java code. I'm going to flip over to the C# code because it is ever so slightly different. So over here in C#, I've already shown you the counter. You have to include system threading for any of this to work. And so the code over in C# is a little different. I still instantiate each one of the objects. So I made counter C1 is a new counter C2 is a new counter. So I made 3 separate objects, counter 1, 2, and 3. But then I use thread start to specify which method in each one of those is going to actually be the one to run. So the reason for this is because in Java, it's assumed because you're implementing runnable that you have a run method. But in C#, you can call any method you want in the object. So what you have to use is thread start to tell which particular method you're going to start with. So C1 my run, C2 my run, C3 my run. That's because in the actual method, I called my run method my run. So you can see that's the method name, and that's what I'm specifying down here. There is a weird syntax of C# that there are no parentheses around this, so you just specify that without the parentheses, which is something to be aware of. So, all right, so I use C1.myRun because that's the name of the method, C2, which is my second counter object.myRun, and C3.myRun. It is possible you could run different methods on different objects, which is a cool thing that you can do in C#, but not so much in Java. Once you have set up the thread starts, then it's the same exact code as in Java. You're going to create a thread for each of them, and you're going to call start with a capital S on each one of them. So thread start specifies which method, and then thread is where you actually create the threads, and start is where you start them. So that's the syntax for both of those, and that is pretty much what you do with threads. You should also be aware that it is possible we could ask you a question about parallel processing on the test, because that is also in here. So you might want to also flip through the for each and the fork join pools. But as you probably remember from the lecture, we spent a lot more time on threads than we did on the fork join pools and the parallel for each. So most likely the question is going to be about threads. All right, so that brings us to the last question, which is on Module 9. There's actually going to be 2 questions on Module 9 in this test. The first one of them is going to ask you to do something with a linked list. So in class, we dealt with building a node class, and then I had you add, remove, add to end, search. These are all common functions that we're going to ask you to do. So in this example on the test, what you're being asked to do is implement the delete function, delete node, and you can see that we're giving you the header here, and we're specifying that you have to add in some code on there to actually do the delete. So again, I'm going to pretty much just pause, and then I'm going to show you the code for how to write that. So you should probably practice add, add to back, delete, search. These are all the things you want to do. There are examples in the lecture again in the video if you want to go back and look at that. And you're also doing these things in quiz number 10, so you may have already seen them in there as well. All right, so I'm going to pause, and then I'm going to come back with the code written. Okay, so we're back. In linked list, in this question, what we are being asked to do is we're being asked to fill in the delete method for a linked list, which would delete a node based on a certain number that's being passed in. So what we're going to have to do is we're going to have to walk our way through the list and look for that particular number. All right, so they did provide us with a node class, which is listed up here. And I actually just noticed that in C#, you're going to need to make these public in order for that to work, so I am just going to update that real quick. All right, so in the node class, this part is just going to get copied straight into the code. So effectively, I just took the initial code that they gave, and I stuck that in, and here it is in Java, node public, that's exactly the same. And over in C#, same exact thing is going on here. I just copied and pasted. Likewise, the linked list class, the header of that linked list class is the same. That's just copied out of the text. And so you can see that it creates a node for head, and then I have a constructor that sets head equal to null, which is necessary in order to create a linked list entry. All right, so you're only being asked to code the delete method. So let me be clear that everything I'm about to go through has nothing to do with the question. And if you were actually answering the test question, you would not write this code. There's no reason to write this code. It's extra time and extra effort. I did it just so that you have a more concrete example to look at after the fact. You can grab the URLs off of the here. If you want to go back and play with these afterwards, you just have to hit fork. Don't try to edit. If you try to edit, it asks me if you can have edit permission, and I can't give you edit permission because then you're changing it for everyone. But you can fork it by clicking here and clicking the three dots and hitting fork, and then you'll get your own copy in Replit. So the URLs are there for Java and C#. They are pretty much the same URL, except they have a C at the end for C#. All right, so having said that, I went ahead and I added in an add method. So this was not asked for in the question, but this is just to add a new node in there. So it takes in a data field, which is an integer, and then it adds the new node. What it does is it creates a new node. So node, new node, gets new node, and then I have a constructor in my node class that takes data and automatically fills it in and sets the next to null. So I'm utilizing that constructor to generate me a node that already has the data in it. I'm setting the next pointer on the node to head, and then I'm setting head to the new node. And as I've said before, I need you guys to get in the habit of just drawing this every single time. So let's talk through real quickly the add method, which I know is not what we're doing here, but we started off with head being null. Okay, so let's look at the circumstance where head was null. So what it says is it creates a new node called new node, and it's going to have on it an actual node. We fill in the data, so let's assume that they give us a 2, that's going to go into the data field, and the constructor for new node sets the next to null. So that's what statement number 30 does, line number 30 there. Okay, so line number 31 then tells us new node.next, which refers to this right here. New node.next points to the same place as head. So what that's doing is it's updating new node.next to no longer point there and instead to point to the same place as head. And then the last line, line 32, says head is going to point to the same place as new node. So instead of this pointing here, it's now going to point here. And so as you can see, you now have head. It points to a node that has a 2 in it, and the next points to null, just like it's supposed to. So we have successfully inserted. So that was the case where there was nothing in the list. Let's go through that same code again, except this time, let's do it where there's already something in the list. So in that case, head points to a node that already has a 2 in it, and its next points to null. So that's the same picture as we had before. So now, node gets new node, new node gets a node. And again, we're going to put the number 3 in here randomly because you're going to fill that in. And when we start off, its next points to null. All right. Line 31 says new node's next, which refers to this guy right here, is now going to point to the same place as head. So new node's next is no longer going to be pointing to null. It's now going to be pointing to head. All right. And then the last line, 31, says head is going to point to the same place as new node, which has the effect of that. All right, so I think you can see here that if we erase all of the junk around that, you now have created a circumstance where head starts off and points to one node, which has a 3 in it. Its next points to another node that has a 2 in it, and its next points to null. That's a valid list. If I were to draw that more succinctly, it will be head points to a node with a 3, which points to a node with a 2, which points to nothing. So what this code is doing is it's inserting a new node at the front of the list, and that's the simplest way to do it. That's why I did it that way. There is also code for adding to the end of the list that you have seen before in lecture, so if you want to refresh your mind on how to do that, you can go back and do that. You're going to need a loop that's going to move you through the list to add it to the end. All right. So I also, again, not really asked for in the question, but I also gave a print method here, which just allows me to print out all of the data in the list. So effectively what I'm doing here is, again, I'm going to just start off with head, and we're going to put a bit of a list together. So I'm going to have a 7 and a 6 and then a 5 and then a null. Okay, that's a 5. All right, and so what I'm doing is I'm saying node temp gets head. So I'm making a new variable. It's called temp, and it's initially going to be pointing to the same place as head. All right, and then I say draw the list again. Head, sorry, I pressed clear instead of clearing off the thing that I wanted to. All right, so I had my temp, and it's pointed to the same place as head. All right, so the next line is line number 37 here. It says, while temp is not null. Well, is temp null? Temp refers to this, and that is definitely not pointed at a null. It's pointed at a node that has a 7 in it. So we're going to go into this loop at least once. It says system.out.println temp.data. So temp.data is that 7. So it's going to print out a 7. All right. The next line says temp is equal to temp.next. So temp currently is pointed here. Temp's next refers to here. So effectively, it's going to point temp to temp's next. That was line 39. Now we're going to go back up to the top of the loop again. This time, is temp equal to null? It's not, so we're going to go into the loop. We're going to print out the data out of there, which is that 6, and then we're going to set temp to temp's next. So temp's next is this, and what we're doing is we're setting temp to that same location. So temp is no longer pointed to here, it's now pointed to here. I'm going to go back through the loop again. Temp is still not null, life is good, print out the number that's inside the node, that's temp.data, and then we're going to set temp to temp's next. So temp.next refers to this guy. So what's going to happen there is temp is no longer going to point where he points, he's instead going to point to the next, which has him pointing to here. Go back up and start the loop again, while temp not equal to null. Well, temp is equal to null, so therefore it's going to exit and this method is done. All right, and the final output was 765. So you can see this successfully prints out the list. So that's how you do a loop to move around inside of a linked list, and you're going to see that that's actually going to be very useful here when we do our delete method. All right, so again, none of that was specifically asked for. That code is literally identical in C# and Java. There is no difference except for that system.out.println becomes a console.write line. But other than that, the code is 100% identical. As a matter of fact, for the delete method, the code is also 100% identical. There is no difference between C# and Java here. All right, so the code that you were asked to write was a delete method. So this is the delete method. I will tell you that this is tricky. And it's not something you're going to get just thinking about it. You're going to have to draw the list. So there's a couple of different lists that we need to think about. So one list is that we have head, which has nothing in it. That's one possibility. Another possibility is that we have one node in our list. We'll put a number in there. And then a third possibility is that we have a big long list of numbers. And there's even a condition there that we have to deal with where perhaps that last node might be special. So we're gonna have to deal with that in a minute. But let's take them one at a time. Let's start off with head is null. So let's think about this for a moment. If the linked list has nothing in it and they're asking me to delete something, what am I supposed to do? Well, the answer is there's nothing to do. So either, depending on what they ask you to do, but this question was not very specific about it, it just says implement delete, add code here. So they're not telling you what you're expected to do, but honestly, they asked you to delete something from the list, you're done. So that's the first condition that I'm dealing with in here. I have a public void delete, and it takes in the number that I'm trying to remove. I'm just going to call that remove. I'm simply going to check head, and remember, head is accessible to me because I am in a linked list class, and the linked list class has a node head at the top. That is the main pointer that points, or the main link that points to our linked list. So I'm checking to see if head is equal to null, and if it is, I'm simply returning. Bada bing, we're done here. All right, so that's the simplest case. Let's take a look at the second case. So we had head was pointed to one node, and it has a value in it. Okay, so if they ask me to remove one node, and the node that they happen to ask me to remove is the node that's there, then this is really, really easy. So if they're asking me to delete 2, meaning the number 2, then I just have to check, is head's data, which is 2, equal to the number they're asking me to delete? If it is, to delete that node, I simply just change head to null. Boom, done. It's gone. Okay, so that's my second condition here. If head.data is equal to the number that I'm being asked to remove, head is simply set to null. And you might say, that's not what you wrote. You wrote head equals head.next. It's the same thing. Head.next is null hanging off the end of that. So just to be 100% clear on that, here was my head. It had a 2 in there, and the end of that node pointed to null. So the question was, is head.data, which is that 2, equal to the number that I was asked to remove? And the answer is yes. Then I'm changing head to head.next. Well, head.next is this. So I'm changing head to point to head.next, which has the effect of making it so that head now points to null, because that's what head.next was. Okay? All right. So those are the two simplest conditions. You gave me a list with nothing in it. You gave me a list with one node, and it had exactly what I was supposed to erase. Cool, life is good. Now let's deal with the slightly harder conditions, which are there is more than one thing in the list, and or the thing that's in the list is not the very first thing that I need to get to. So what I'm going to do here is I'm just going to draw that list again, and I'm going to start off with head, and I'm going to put a 7, and then a 6, and then a 5, and then a null. Okay. So we're going to imagine that they're asking me to remove 6. Okay, so how are we going to do this? Well, logically, what I want to happen is I want that to happen. That the pointer that's there, or the link that's sticking out of the 7, I wanted to bypass the 6 because you're asking me to delete the 6. So that's the simplest answer. But in order to do that, I have to be able to do what? So if I have a temp pointer, so that's probably what we're going to do. We're going to make a temp, and we're initially going to point it to the same place as head. But if the node that they're asking me to delete is not that very first node, but it's the second or the third node, then how am I supposed to actually remove the number out of there? Well, if the thing that they're asking me to delete is in the first node, that case has already been dealt with. We dealt with that in the previous code here. So remember, when we were dealing with the head.data equals remove, the way I drew it, there was only one node in the list, but in actuality, regardless of whether there was one node or multiple nodes, this was checking if the answer that I'm trying to look for, the node I'm trying to remove, was the very first node in the list. If it is, then I pointed it to next. That's specifically why I wrote it that way, because even if the list has more than one thing in it, this will successfully remove from the first node if that's what we were trying to do. So we can be relatively certain that it's not the first node that they're going to ask us to remove if we're getting down to this block of code. All right, so we're going to redraw this again. So we have head, it points to 7, which points to 6, which points to 5, which points to null. So we know that the thing that they're asking us to delete is not going to be in that first node because it would have already been dealt with. And we know that the list is not empty. So realistically, it must be the second or later node that they're asking us to delete. So to be clear, again, we are trying to remove 6 is the particular example that we are trying to do here. All right. So What we're going to do is we're going to make a temp pointer, and we're going to point it to the same place as head. And the trick of this is the important pointer, the link that matters the most is the one that I just highlighted in purple. That's the one that I need to change. In order to do that, what I'm going to do is I'm going to check to see if the second node has the data that I'm looking for. If it does, I'm going to change the thing that's highlighted in purple to point past the node that has the data in it. So the code for that is I'm going to say while temp.next is not null. So temp.next refers to that guy. That is not equal to null, so I'm going to go into the loop. We're going to see why that's necessary in a moment. It's not actually necessary for this case because we're deleting the second node, but if it's any later node, that absolutely is necessary. So now we're going to check to see if this is the node we're trying to delete. If temp.next.data, and you can see that temp.next.data refers to that 6. If that's equal to the remove, which is the 6 that we're trying to remove, which it is, then we're going to set temp. I'm just going to erase all of these again just so that I can be very clear as to what's happening here. So I'm going to bring that back to a sane state and bring this back to a sane state. And we're going to go back to the red pen. All right. So that's the current state of affairs. The statement says if temp, which is this guy, .next, which is that guy, .data, which is the 6, is equal to remove, then I'm going to set temp.next, which is that, equal to temp.next.next, which is that. So to be clear, I'm going to change this first arrow, the one that has a 1 underneath it, to link to wherever the second arrow is. That's what that statement on line 20 does. Temp.next is equal to temp.next.next, that guy. So when I draw that out, what's going to happen here is that is no longer there. It is now going to link to there. Okay, so at this point, you'll notice that the node that has the 6 in it, there is no longer a way to get to it. I can't start off back at temp and get to it, and I can't start from head to get to it. It's just kind of dangling out there. It does have a next that points to the node that has a 5 in it, but I can't go backwards because this is a singly linked list. So there is no way for me to get to that node, and effectively what's going to happen is the garbage collector is going to come along, realizing that there's no way to get there, and the garbage collector is going to get rid of it for us. And now, having garbage collected, you can see that that list looks correct. I have a head that points to 7, that points to the 5, which is what's supposed to be there. So that was the case when it was in the second node. Let's take the last case where it's in the third node. So in this case, we still have a 7, that points to a 6, that one points to a 5, and this one points to a 4. And then that is a null at the end. Okay, so now what we're doing is we're doing a remove on 5 this time. Okay, so let's trace through the code. We start off with a temp, and that temp is going to point to head, because that's what we were told to do on line 16. We make a new link, it's called temp, and we point it to the same place that head is pointing. Then on line 18, we are going to say while temp.next is not equal to null. So again, temp.next refers to this guy over here that I'm making fatter. While temp.next is not null, it is not, so we're going to go in to the loop. If temp.next.data, temp.next.data is that 6. If temp.next.data is equal to remove, well, it's not. 6 is not equal to 5. So we're going to go to the else in this case. At this point, what we're going to do is we're going to set temp equal to temp.next. So again, let's look at where those things are. Temp is this guy, and temp.next is this guy. So what we're doing is we're setting temp equal to temp.next, which has the effect of moving him down to point to here. And now we're going to go back up to the top of the loop again. While temp.next is not null, temp.next refers to this guy, that is not null. So we're going to go in and say if temp.next.data, temp.next.data is this 5. If that is equal to remove, ding, 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 it is. So now we're going to set temp.next, which is highlighted in blue this time. So temp.next is going to be changed to temp.next, which is temp.next.next. So the blue link is going to be moved over to temp.next.next. That has the effect of disconnecting that link right there because we just moved it over. And now you can see that the garbage collector can come along and erase the 5 like it was supposed to. And magically, we have successfully erased the list. The temp pointer is no longer, or erased the node that we were supposed to erase. The temp pointer is no longer necessary. Okay, so this works in all conditions. I'm just going to clear the screen at this point. And what's going on here is that you are being asked to write a delete method which can go through a linked list and successfully remove one of the nodes out of there. Just to test it, and just so that you can play with it if you want to make a fork of this, I did make a list that has a 2, a 3, a 4, a 5, a 6, and a 7. Please note that I'm adding to the front of the list, so the 2 ends up being the last one, and then the 3 comes in front of it, then the 4 comes in front, then the 5, then the 6. If you call the print method right after you make everything, which is this guy, you're going to see a list that says 765432. And then if we attempt to do the remove method on removing the 2, you're going to see that the second time it prints the list, the 2 is missing. And it'll work regardless of which number you put in there. It's a little hard to see where that ends, but that is the first output. And then the second output, notice that the 2 is missing from down the bottom. And of course, I could remove the first node. And generally, when you're writing code like this, you would always want to check that it works in all circumstances, that it successfully removes the first node, the middle node, or the last node. And in each of those cases, it does work. There's the 7 gone again. All right. So as I said, this code is available in both Java and C#, although honestly, they are identical with the exception of the system.out.println becoming a console.writeline. So that is question number 7. So to be clear, what do you need to know for question number 7? You need to know how to add a node into a linked list. You need to know how to remove a node out of a linked list. You need to know how to add it into the back of a linked list versus the front. And you need to know how to do a search in a linked list. All of those are in the examples in the lecture. So if you're having a hard time with that, you can go back and review that lecture video. But that is what you're going to be asked to do, one of those things. Right? So make sure you know how to do them. All right. The final question in the exam is with regard to a binary search tree here. And so to be clear, this could either be about a stack or a queue or a binary search tree, which are the other things that are in module number 9. So in module 9, we covered linked lists, doubly linked lists, stacks, queues, and then trees. So you're going to have to question on linked lists, and then you're going to have a question on one of the other things. It's not going to be doubly linked lists. We will not ask you to code a tree. That is not a valid question, but we may very well ask you, like this question is asking you, to trace through a binary search tree. So what you're being asked here to do is to do a post-order traversal. Remember, there were 3 ways that you can read numbers out of a binary search tree. They were pre-order, in order, or post-order. And the difference is, inside of the code, which order you're doing the recursion call. So you're going to have public void, and then you're going to have, in this case, post order. That's the name of your method. And it's going to take in a root pointer, which is going to be a node called root, or you can call it whatever you want. And then you're going to have 3 statements. If root is not null, then you are going to make the following calls. Since this is post order, you are going to do a recursive call to root.write. I'm sorry, I said that wrong. To root.left. Then you're going to make a recursive call to root.write. And then you're going to make a print statement. using root.data. Okay? The only thing that is different between a pre-order, a post-order, and an in-order is the location of the print statement, which obviously could be a system.out.println or a console.writeline. But this is post-order because it's happening after the left and the right recursion. If I simply move this up to the top, it's a pre-order, and if I move it into the middle in between the two, it's an in-order traversal. The values that you're going to get are going to be different in each case, but that is a post-order traversal. You won't be asked to write that, but you may very well be asked to trace one of the three of them, and so we're going to go through tracing this one. So I'm going to clear the screen real quick, and we are doing effectively, in each node, we are going to go left, then we're going to go right, then we're going to print. And that's the easiest way to do one of these. So you're going to have a left, a right, and a print on each one. And the way that's going to work is we're going to start at the top, because that is where the top of the tree is. So this is our root. So the first thing we're going to do is a left recursion, which is going to bring us to here. All right. First thing we're going to do there is a left recursion, which is going to bring us to here. First thing we're going to do there is a left recursion, which is going to bring us to here. And then the first thing we're going to do there is a left recursion, which is going to bring us to this implicit null that's down there. That is null, so it's just going to pop right back off the stack. All right. The next thing we have to do is a right recursion, which is going to bring us to an implicit null there. That's going to be null, so it's going to pop right off the stack. And so the last thing that it's supposed to do is a print, which is going to have the effect of printing out the number 1. At that point, you are done with everything to do with this node. You went left, you went right, then you printed. So that pops off our stack, and we are now up to the node above it. So I'm just going to keep track in a different color as to which nodes we have completed. So that node's done. All right, the node above it, it told us to go left. We have now successfully done that. So now it's going to try and go right. Well, there's nothing on right, so it recurses right. It then checks if root is null, which it is. So it pops off, and right is done. So left is done, right is done, and the last statement there is a print, which is going to print out the number 9. All right, and now at this point, that node is also done. We have gone left, we have gone right, therefore we are done. So we're back up to the node above it, which was the 13. It went left, so now it's told that it's supposed to go right. So it comes down here, and we keep track of the fact that we've done right. So this node, 24, it's going to try and go left, which is null. It's going to go right, which is null, and then it's going to print out the node. And now that node is done. All right, so we're back up to the 13 again. We went left, we did everything we were supposed to do there. We went right, we did everything we were supposed to do there. So the last thing to do there is to print, and that's going to output, I'm just going to put commas in between these, the number 13. All right, and now that node is complete. All right, so now we're going to come back up to here where we were previously when we started. That sent us down a left, so the next thing we're going to do there is we're going to go right. Well, that's going to bring us to here. All right, so in this node, we are supposed to go, left, right, and then print. Left, right, print. Left, right, print. Left, right, print. Okay, so we got to this node, the 76 node. It's telling us to go left, so that brings us down to the 50 node. It tells us to go left, that's a null, so nothing to do there. It tells us to go right, that's a null, nothing to do there. And so the last thing to do there is to print, which gives us a 50. All right, back up to the 76 node. It told us to go left, we did that, so now we're going to go right. So that's going to bring us down to here. This one tells us to go left, so we're going to go down to here. All right, this one tells us to go left, which there's nothing there. Right, nothing there. And so print is going to give us a 91. All right, and so now that node is completely done. All right, so we're back up to the 94 node. We have gone left, so we try to go right. There's a null there, so nothing to do there. And then finally, we need to print. So that's going to give us a 94. Okay, so that node is now done. He's done everything he was supposed to do. And so now we're back up to the 76. On the 76, we have gone left, we've gone right, so the only thing remaining to do is print. So that gives us a 76, and that node is now complete. And so that's going to bring us back up to the original root node, which was a 37. We've gone left, we've gone right, so the only thing left to do is print, and that's going to give us a 37. So if I clear out all of the data that was on here, you can see that this particular tree is going to give us a post-order traversal, which looks like that. You're going to get 1, 9, 24, 13, 50, and 91, 94, 76, 37. So that is a post-order traversal. Just for the record, I'm going to do a different one for you. I'm going to do a in-order traversal. So in that case, it's going to be left, print, right on each one. Left, print, right, left, print, right, left, print, right. Okay, so left recursion, print statement, right recursion is what we're talking with. All right, so we're going to start up at the very beginning, and we start off with left, which is going to bring us down to here. That gets us to here. We're supposed to go left, so that's going to bring us to here. We're supposed to go left, so that's going to bring us to here. We're supposed to go left. There's nothing there. We're supposed to go print. So that gives us the number 1. All right, and now we're supposed to go right. There's nothing there, so this node is done. Back up to the 9. We did our left. Now we're going to do our print. That gives us a 9. And now we're supposed to go right. There's nothing to the right, so that node is done. Back up to the 13. We did our left, so now we're supposed to do a print. And now we're supposed to do a right, which is going to bring us down to here. We go left, there's nothing there. We do a print, 24. And then we're going to do a right, there's nothing there, so we're done with this node. All right, that's going to bring us back up to the 13. We're done with everything we were supposed to do there, so now we're back up to the 37. We've gone left, so the next thing we're supposed to do is print. There's our 37, and now we're supposed to go right. Okay, that's going to bring us to here. We're supposed to go left. That brings us here. And now we're supposed to go left. Nothing there. We're supposed to print 50. And then we're supposed to go right. Nothing there. All right, that brings us back to the 76. We went left. I just forgot to cross it out. So now we're going to do a print, which gives us 76. And then we're finally going to do the right, which brings us down to the 94. There we're supposed to go left, which brings us down to the 91. We're supposed to go left. Nothing there. We're going to do a print, which gives us the 91, and then we're going to try to go right, which there's nothing there. Back up to the 94, we've done a left, so now we're going to do the print, 94, and then we're going to go right, which there's nothing there. So we're done with all that, we're done with all this, and we're done with all this, and the method ends. And what you will notice is that the order of the numbers from a binary search tree with an in-order traversal come out in sequence: 1, 9, 13, 24, 37, 50, 76, 91, 94. So that is an in-order traversal. This one was a post-order traversal. And a pre-order traversal, you would just do print, then left, then right. So that's the little magical shortcut for doing any one of those traversals. I showed you the code for doing them as well, but the actual output for this particular question on this sample quiz would be 1, 9, 24, 13, 50, 91, 94, 76, 37, because you are supposed to do a post order. That's what you were asked for in this. So that completes the run-through of the test. I hope you guys found this helpful. The most important thing that you get out of this is these are sample questions. You're not going to get this exact question on the test, obviously, but it is going to be something that is from at least that general genre. Good Lord. All right, so the last question on the test, which was question number 8, was specifically about something in Module 9. And as I said, given that you have already dealt with linked lists, we're not going to ask you about doubly linked lists, and there is no coding of trees or graphs. You will not be asked to code trees or graphs. That's not part of this class. You'll do that in data structure. But you may have to do a in-order, pre-order, post-order search of a tree. You may have to deal with pushing stuff into a stack or pushing stuff into a queue. And you definitely need to remember, for a stack, you have push and pop. And remember, with a stack, things go in on top. So if you push a 2 into a stack, and then you push a 3 into a stack, and then you push a 4 into a stack, and then you pop from the stack, the thing that you're going to get is 4, because you're getting the last thing that was put in, last in, first out. That is a stack. For a queue, you think of a grocery store. If I in queue the number 1, and then I in queue 2, and then I in queue 3, and then I in queue 4, and then I dequeue, you'll note that they're all going in a line just like in a grocery store. The dequeue is going to happen to the 1. This is an example of first in, first out. The first person to get in queue is the first person to get dealt with at the grocery store checkout line or whatever it is. So that's what you need to remember for queues. Peak, in both of these cases, is a keyword that allows you to look at what's at the front of the queue or what's on top of the stack without removing it. The difference between peak and pop is that pop actually removes it and it gives you back a 3, whereas peak just looks at it. Likewise, peak on a queue just tells you that the number is 1, that's the next person in queue, but it doesn't actually remove them out of the queue, whereas dequeue actually does remove them out of the queue. So that's important to know there, and that's generally the Module 9 stuff. So that's going to end up being your question 8 and your question 7. There were 2 questions from Module 9 on the test. Why does it move some of it but not others? I don't know. That's very weird. All right. For question number 6, that's going to be on threads. Question number 5, as I said, is a combination of these 2. That's going to be question number 5. It's going to be both on file I/O and exception handling, so you're going to have to read or write from a file and deal with all the exceptions that you might have to deal with there. Question number 4 is going to be off of recursion, so definitely make sure you know how to trace and write recursion. Question number 3 is going to be on Module 3, which is going to be the object-oriented stuff, so make sure that you know how to instantiate objects, how to do public, private, protected, polymorphism, abstract classes and interfaces, and casting. Question number 2 is going to be on pass by reference, pass by value. That's going to be the one where you're passing stuff in and out of a method. And then finally, question number 1 is going to be off of the review from 1322. So questions are mostly each worth about 10 points. Obviously, there are 8 questions. There's 100 points, so a couple of the questions are worth 15. Make sure that even if you don't know the answer to the question, put down as much information as you can. Give us the header, give us the if statement, give us the loop, give us the bits that you know how to do, even if you don't know the final answer, because you'll get most of the points that way. If you give us a blank page, you get 0, because we can't grade nothing. So give us something that we can grade. Having said that, don't just write everything that you can possibly think of in there. Make sure you're not writing in pseudocode. And other than that, I wish you all the best of luck on the test. You're going to do great. Don't freak out. It's not that bad. If you understood everything from this test, you're going to do fine on the final. This test is slightly harder than the final, insofar as I picked the worst examples for this example, or for this the practice test, because I want you to be as familiar as you possibly can be with the material. So that's the end of the review. I hope you guys have a lovely remainder of your break, and if you have any questions, feel free to drop into office hours or send me an email. Take care. Bye-bye.